Good evening, YouTubers. Welcome to episode 75 of Shrigleytube TV. Just want to say a massive thanks to everyone that tuned in last week's video, and also to the midweek video all about Tim's rally and escort at Goodwood. That was great. That, hope you enjoyed watching that. So a lot of positive comments have come through, so great to see that people are watching the videos that we're making. This week got all sorts going on. Did a bit on Glenn's engine, did a bit of Pete's 1012cc engine. It ended up being a 1012 and 998, but you'll learn about that shortly in the video. And we also went to visit Vince at Merlin Motors, which was really nice. He got some old pictures out which are on at the end of some space framings, etc. So I hope you enjoy what you see, and thanks again for the comments, and I look forward to seeing you all next Sunday at 7. Bye for now. Good morning, YouTubers. I thought I'd start this week's video off with a bit of a visual. So we've got the camera turned around to say hello. Had a good, nice weekend break with the kids. Well, I had Sunday with the kids and the missus, which was great. So fully recharged, ready this morning to come in and tackle the complete mess of a workshop, which I have to admit, I have let it get worse, because now that we've got the new unit being made, obviously I'm just busy getting on with the job, and then we'll start emptying this unit into the new unit and create exactly the same mess in the new unit. No, I'm going to try and be tidy and make the job a bit more professional, to be honest. That's what I want to do. Anyway, I'll turn the camera around. We're going to talk about Baz's engine. We're going to go to Bob's later with the rods that are reamed, and we're going to finish hone them on his posh honing machine. So we'll do a video on that later. But for now, I'll turn around and say this is Baz's engine that he dropped off on Friday. So it was just a head gasket issue. So I said, look, we'll just put a head gasket on it, and we're going to put this single 40 on it for him as well. So I've just cleaned the pistons off, decoat it. I've given the head a skim, given a bit of a decoat, check the valves are all seating properly. All that is absolutely fine. You'll notice it's got bigger valves, so it's on a 1.3, 1.125 valve, opposed to the standard imp sport size. So that's the biggest you can go to on the standard sport seat. So that's all good. Obviously the pistons have been machined to make room for the bigger valves. So these have been machined. The cutter's caught that. I was thinking, has a valve dropped at some point? But it's actually the valve cutter that's just caught it as someone's machined it. And then I noticed something. If you look, everything's stamped. So if you look, we've got is it a J78 it says there? E78. And if we look at the engine block, we can see it was cast on it was manufactured on the 29th of the 5th, 1978. So I was one then. Anyway, so all the numbers match, so that's good. So these pistons are matched to this engine. However, I don't know who built it, but someone's took it apart and put it back together in the wrong order, because if we look at the top of an imp block, you always get a letter sizing. So we've got a C, a B, a C, and a B. So the piston should match. So this is number 1. So number 1 should be a C, but it's got a B in it. Number 2 should be a B, but it's got a B in it. It got that one right. This one should be a C. Yeah, it's got a C in it. And number 4 should be a B. That's got a C in it. So we just got one pot. Yeah, we just got 1 and 4 mixed up, that's all. Anyway, it's not an issue, because we're talking like half a thou, so 5/10 of a thou. The difference in size is minimal. But this is something in the 80s, when they were manufacturing engines, they started to try and clamp down on like oil consumption. Before that, it wasn't a massive issue. So when we talk about clearance, we're talking the piston skirt clearance to the cylinder bore. So obviously different materials expand at different rates. We've got an iron liner and we've got an aluminium piston. So as it gets hotter, the iron is very stable. It doesn't grow much, but the piston does grow because it's aluminium, and obviously the piston gets really hot. So we have to have a clearance in the bore to allow the piston to grow without it picking up and damaging the liner. So what started happening was, when they started to close these tolerances down, obviously you end up, we have pistons one size, and then you could have a hot day when you machine the block. So what I'm trying to say is, if you machine this block, say I see it in here, I'm going to divert now, aren't I? Next to the heater, if it's a warm workshop day, I've had the heater on, and I bore that hole with a set size on the tool, and then the next day I come and bore this hole, and I haven't got the heater on, so it's cooler. what happens is this ends up being a bigger hole because it was bored cold. Because what happens with this one is when it's bored and it's hot, it's grown, so it takes less out. So when it shrinks, it cools down, it ends up smaller. Whereas because this was cold in its clamp position, in its smaller position to start with, and I ploughed through it, it took more out. Does that make sense? And the same issue with when they're manufacturing engines. So what they did was they used to bore the blocks, try and keep them all one size, and then they had 4 piston sizes, A, B, C, and D, and they'd measure each bore, and depending on whether it was like which size of the nominal size it was meant to be, depended on which piston you picked to put in it. So all the pistons were machined and then graded A, B, C, and D, and all the blocks were bored and graded A, B, C, and D. And then all the assembler had to do was, he knew that if he had a stamp for C for number 1, he'd go and get a C grade piston, because that would be the closest to the tightest tolerance they could run without it picking up, you know. So obviously they want it as tight as they can in the bore, but not so close that when it expands, the piston grabs and causes a seizure. So yeah, I think I've explained that without tying myself in too many knots. It's just ways of, I mean, modern technology now, if they come to manufacture an engine, the tolerances are so close, you know. They're wonderful. They have like temperature controlled machines, so the machine measures as it goes along, and if it starts to go big, you know, they're just very, very clever at getting it right. But back in the day, everything was manual, you know, or manually, or like they called them tape machines, where the machine used to use a piece of tape with holes in it, and that told it its next instruction, you know, numerical like control. Anyway, we're going to divert in. Right, brilliant. We've done that. We'll go and have a look at these rods and talk about them for a second. Right, okay, well, this is Glenn's engine, and the plan is, the new plan, I was going to strip it to 1,000,000 pieces and start skimming the block, but then I thought to myself, wouldn't it be a better idea if we made it so I could put the pistons on the rods while the crank's still in, and put the pistons on the crank and the rod and do like a dry build? Because what I want to do is put the new cylinder head on with the new pistons in, and then actually get a witness mark by just dropping the valve down with no valve spring on and seeing where it lands on the piston. Because we can measure it so our heart's content, but you can't beat a witness mark. It just makes the job easier. So what we'll do is we'll put these pistons on these rods and drop them into the engine, and then put that new head on, and we'll get some witness marks, and then we'll transfer the new pistons over to the milling machine, and we'll do the machine cutout for the piston valve relief, you know, so that it's got valve clearance at top dead centre. But what I wanted to say was that the new pistons are on 18mm pin. So these obviously were on 11/16, so I've reamed most of the material out, but I've left about 3 thou, he says. I've left it tight basically, and the reason I've done that is a reamed finish is not sufficiently acceptable for a race engine little end bush. So what we do is we take these to Bob's now. Bob's got a posh honing machine. Hopefully I'll be able to get a video of the rods, and we'll get them on the honer, and we'll put a nice hone into the little end bush and create the correct clearance, because it's quite important, this clearance. You got to remember that bronze bush, it has quite an important job. It only splash fed oil, and the clearance is critical, because not only has it got to obviously control the position of the piston, it also has to transfer the heat back into the rod from the piston, because, you know, there's not an awful lot of the piston for it to lose its heat. I mean, it's actually quite a full-bodied piston, that, but on a slipper piston especially, you've got to look at where the heat path is back to the engine, you know, from the piston. So a lot of it goes through the pin, so the clearance is critical. We get that spot on. Anyway, more about that later. Hopefully by Tuesday morning we'll have this going together, and we'll get a witness mark, and then we can start machining pistons, and then we'll take it all apart, clean it all, and then we'll get a build on. Just popped out to Nick's place to see the cylinder head that we just skimmed, and he's showing me the engine that he's building. What were you just telling me, Nick? This is an injection engine or something?
The block's an injection block, yeah, one of the last blocks, but he's putting it in an early car.
So an XJ6 was like, the last ones I remember, like F-Reg 89 or something. So this is a late block.
Yeah, because it's an injection block.
Yeah, it's massive. What's all this about? Is this like an expansion or thermal thing? The water passes through there, is it?
Yeah.
Right. It's, you know what? It's a lovely thing, isn't it? Yeah, I bet it's heavy.
It's very, very heavy.
And it's 4.2, so it must have like at least 100. I mean, 'cause it's not a
It's
big.
a long old stroke, look.
Yeah.
There's a couple of rods down there.
Oh crikey! Yeah, look at them.
It's a long old fires every third lamppost.
Every third lamppost. Because it must be 100 mil plus that, because that can't be bigger than sort of 89. Is it 90 mil something like that?
I don't know.
You know what? It's too cold. Oh, so awesome that, mate. And what have we got over here, Nick? We're just looking for exciting things to talk about.
550 gearbox.
And it's broken.
It is broken. It's worn. It keeps those thing kicking the lever through the gate, I think, and worn all the teeth off.
Oh, and the
So it
synchro.
doesn't like to engage.
Ah.
That's just where it goes on the dog teeth. On the, so that's it in cog. The bolt ring's all right. That's okay
Right?
because you've got plenty of
Clearance, yeah.
clearance there.
Yeah,
The
yeah.
bolt ring's all right. It's just I don't know what.
You ever put these in a bowl of hot water and measured them? Saying that they're not bronze like an imp one. An imp one's a bronze. So even though they grab the synchro, no problem there. When they get hot, they just go straight up against it.
Yeah,
Because
but
they expand.
it shines that up if it does that.
Ah, right. Does it?
Yeah, it shines it all up.
Yeah, it looks okay, doesn't it? Yes. Very good. Yeah.
It is because I've measured it.
So is it a transaxle?
Yeah.
Would it fit an imp? Mind you, I don't know if the imp would have enough power to turn that.
It's not going to drive it, is it? It's like 4 bearings on each shaft. It's too much for it.
That's 100 horsepower down the drain, isn't it?
Yeah,
Right,
I think the transmission would have it.
Yeah, well, thanks
You
for...
might get 35 out of it.
Yeah, cheers for that, mate. Right, well, thanks for showing us around, Nick. It's interesting. Can I just say something? You've
Yeah.
got a posh workshop, but I've got a bigger ultrasonic cleaner than you.
It's not all about size.
That's what my missus says when she's being nice.
So you'll have some points.
Right, we're on, Nick. Right, Nick's just let me do a bit of video. We're not supposed to video anything in his workshop because it's all like customer confidentiality. But I just seen this engine and I thought, Nick, tell me all about it. This is a Porsche engine. It's
Yeah, mechanical
air
fuel
cooled.
injection.
Mechanical. Is that Kugelfischer?
No, it's Bosch.
It's Bosch, is it?
Yeah.
But some of them Kugelfischer,
Not on these.
right? So it's Bosch. Wow.
Might be on the racing ones.
So it has a... Oh, I see. So
Individual throttle bodies, look at all the rods.
let's get a mechanism going.
Adjusting all them in.
Oh, imagine balancing them.
You don't worry, I don't have to imagine it. I'm doing it.
Oh, you're doing it. Oh, yeah, look at that. So, it has obviously the metering unit has speed, and it also has a throttle position to determine where to put the fuel.
It's that arm.
Yeah.
See the arm moving?
Yeah, that's the rate.
That's the mixture.
Yeah.
It's got that's the heat to turn the choke off.
Oh,
So
it's
that's
got
the
a
choke.
cold start system on it.
It's got a barometric thing if you're up a mountain in Switzerland to adjust the
wow.
mixture.
So if it's having a good air day, it puts more fuel in, and if it's
Yeah.
having a bad air day,
Yeah.
if you're up a mountain and you've got no air pressure, it pulls the fuel out.
Yeah.
And this is what year is this?
74.
Let's just get a video of this mechanism working here. Look at that.
No, 73. So.
How beautiful. You can see why these are worth so much money. They're just awesome, aren't they? And it's air cooled as well. That's the crazy thing. I've always wondered.
Well, it's the oil that cools it essentially. There's a big oil cooler down there.
Ah, is that how they do it? They fire oil everywhere and take the heat out of the oil.
Yeah, take the heat out of the oil.
Oh, I didn't
I mean,
know
that does fan over the top of the engine, but it's the oil cooler. See that grey channel there?
Oh, right.
And that back corner of the engine, the front corner of the engine is where the oil cooler is.
See,
You
very,
have an oil cooler on it, wouldn't there?
very clever. Very, very clever. Lovely. Well, thanks for showing us around. The Germans, yeah, well, that's why I've got a Volkswagen
Yeah.
Passat, because the Germans are the best at making stuff.
Right. I think they might have lost their edge by the time they made Passats.
No, mate, when they made that B5 Passat, they made it really well, trust me. It's done
That
about...
the one that wouldn't start the other morning when I rang you.
It's done 300,000 miles with no love, and it still loves every day that it lives. We're really sorry about the audio on this, but we've got a compressor next to us. This is Bob's honing machine, and I'm just honing the rods for Glenn. It's very kind, I said I can use it. It's got a foot pedal that operates it. Basically, when you press that pedal, it starts to go round. You see? Oops. So I'm going to get hold of it with my glove here. Now, as you press the pedal further down, it actually increases the stone diameter, only very, very slightly. So Bob set it for me, and as I go up and down, you'll see it start to take material out. Just try and put my glove on badly. So we start him going. Then what we do is we bring the rod up and down the stones at full length, like that, and it it's just tickling the inside of that bore. As I press the pedal more, now I can feel it starting to grab more and more. And then what we'll do is we'll take him off, use the full length of the stones so as it wears them uniformly. It's got a good bite on it now, I can feel it working. Right, bring him to the end before we slow him down. Stop him there. Now just find my pin, which I've lost. Where's my pin gone? Oh, there it is. That should go in. Oh look, beautiful. Right, great. So I've just got to do that to the rest of the rods, and then one day I'm going to treat myself to a machine like this. I'd love to get a new Honer. Morning YouTubers, it's Tuesday morning. Had a good day yesterday. Managed to get the little 930 of Bazzi's back together. Just got to sort the manifold and the carb out now. I've ordered a V-band for it, so I'll sort that out and we'll get it on dyno hopefully Wednesday, Thursday. Now this one is the one that got dropped off last week, belonging to Peter. It had the bad liner and the foreign bodies in the chamber, so I've got him on the miller now. I've just, before we start machining it, it had no weld on it, so I'll put a big weld on it because when I'd started to weld it, there was a crack there. May have been caused by the trauma of inside the chamber here. So we've welded it all up now and it's ready to start machining. Now I've put this very high-tech hacksaw blade under the edge, which is going to give us an ever so slight wedge. And I've done that for many reasons, but one of the main reasons is if we take more off this side, it keeps us away from the valve seat edge there. And I don't know how much, I don't want to take material off for the sake of it. I just want to get it flat and the chamber looking half right, so that basically that when we come to match all of the chambers, or if we were to match all the chambers, which you probably won't be doing this engine, the combustion chamber is the same size as the one next to it. So with all this damage, it's all a bit low and bits missing, but if we can get a nice surface on it, it's got the best chance of working properly. So I'll start skimming it and then we'll have a look at it and then we'll do the wheels. Okay, just giving the head a quick skim and it's cleaned up really well. There was a fair bit of bruising to this area here. That's because the head's quite thin the other side of the casting. So when it got whacked, it effectively went a bit shallow. So we've had about, I reckon we've had a good mill off it. Now these wheels ring grooves are like 55 foul deep. So if we put the, where are we at there now? About 20. So we've had a good 35 foul off it on that side, and on this side we've had 40, should we say. So that side will have had about 15 thou off it. So that's because I skimmed it on a wedge, because I put this hacksaw blade underneath it to bring this edge up, because I wanted to keep that valve seat away from the edge, which we've managed to do. So it's hard to explain, but this side of the chamber is quite strong. This is very weak. So it's always safer to remove material from this side. Plus there's lots of plus points, like you get a deeper angle inlet port, and also you reduce the combustion chamber capacity more by taking material off this side, because obviously this is called the deep side of the chamber. So it helps with the compression. It helps in every possible way, really. But the most important thing is that we're taking the material, or the minimum amount of material, off the face, because obviously these aren't being cast anymore, and once you took it off, it's very hard to put it back on again. So we've ended up with a decent bit of material there. It's not too thin. It'll be absolutely fine, this head. We'll put some support screws in to support the chamber there. I'll just get on with redoing the wheel string grooves, and then yeah, we can start building it. Just finished doing the wheel string grooves on this damaged cylinder head. Gotta say, I'm really pleased with it. It's turned out really quite well. All the damage has virtually disappeared now. It's a little on the edge there, but I'll tidy that up with the hurdy-gurdy, so you'll not be able to tell that this head had any damage. This is the wheel string, and as you can see, he fits in there nice and snug now. So there'll be about 15-20 thou protrusion with the paper gasket, and that'll give it the pinch. So as we clamp the head down, when this wheel string sits on top of the liner obviously is ironing quite hard. You get a little flat area, and that's your combustion seal. So they work really well, these wheel strings, to be fair. You know, they're just not a problem anymore. So yeah, it's all good, brilliant. We're going to put the support screws in now. We've got to give them a quick lap, re-spot face all of the head bolt holes, because I've skimmed it on the wedge. Effectively, the bolts holes now aren't at 90 degrees to that face anymore, so we just have to re-drill them, re-spot face it all, and then we can get on. Okay, once again we find ourselves selecting reverse gear. This is the engine that had the bad liner in it. I've just done the cylinder, I'd done the repair on it, and I thought I'll just throw a bore mic down it and see how it measures. I know it's obviously a worn 72.5mm. Now this is what we call a thin wall liner block, so it can't go to 74mm, which would make it 1040cc. It's quite thin, the liner where it passes through the block, so it doesn't have enough material. However, Mr. Mark Maynard, very clever, did an oversized piston at plus 20 thou, which is going from 72.5mm to 73mm. So these pistons are great for repairing what normally would have been a new liner job, a 72.5mm 998 bore. So I thought to myself, it'd probably be all right. It's just a few marks in it, and I thought, oh, you know what? It's so easy at this stage to just put it on the borer, bore it and hone it to 73mm. We'll have a nice fresh bore, and it'll just be guaranteed to work correctly then. So yeah, the attempt of just putting a plaster patch on it and a set of new pistons has gone out the window, and I will get on with boring this and honing it, and then we should still be able to get a build on with it today, all being well. Just finished boring this to 73mm, so you can actually see at the very, very top of the liner there where it barely touched. It was quite hit and miss, because basically this the way this centers on the bore, it has little pores that come out. I think we've been through this before. So you see these little feet here, these come out when I wind this handle. Can you see them coming out? And they go back in again, and that centers the tool. But because we're going plus 20 thou, that's only 10 thou a side, so 0.25 of a mil a side. But because we've not actually gone to plus 20 thou, because that's the finished size, we've only gone plus sort of I don't know, plus 8 thou a side. So it's an 8 thou cut on a bore that was all over the show. So it was a bit hit and miss, but luckily I managed to centralise the tool so that it took a uniform cut all the way down. It did clean up. So a bit of fiddling there, but yeah, really pleased with that now. So we can now get on with, you notice the piston won't go in. That's because the bore is the same size as the piston, and we're going to hone the clearance into it now. So we're going to put a 3 thou clearance in with the honing tool, which is this little machine here. So I'll crack on. We have done loads of videos on that, so I won't go into it, but I'll get it honed because I'm desperate to get a build on with this. Good morning, YouTubers. Really pleased with this engine. I'm glad that I decided to rebore it and put the oversized pistons in, because it's much nicer now. It's got much better chance, and obviously we've got it on absolute what I call road spec tolerance, which is about 2.5 thou skirt clearance, but it was nice and quiet. Now I know the chap's going to look after it and run it in gently, so it should all make a really nice engine. This the head refacing, 99% of the damage came out. There's just one tiny little bit there. I have just gone around with the hurdy-gurdy, so there's no sharp edges. Valves all seated perfectly. It's on stainless valves, so no qualms there. Everything looks good. Wheel string grooves are redone. Obviously the block's faced, so all liners are level, so there's no reason why this shouldn't work perfectly. I just spotted one little problem though. I was wire wheeling the head bolts, and I thought, oh, this one looks a bit, is it me or does it look thin there? And you see that area there where it looks thin? I'll see if I can measure it for you. Now when you're doing one of these engines, the head bolts quite often get overstretched. So it's 361 thou there. If we go there, it's 12 thou down. And what that is when the bolts get over tightened, they stretch. And when they stretch, they go thin. I don't think the camera can pick it up, but it's just thin there. You can see the pitch of the thread actually grows. It goes wider where it's stretched. So luckily I've got these 930 heads engines I've been stripping, so I've got some nice new standard bolts there we can just swap into it. So I've got to go to the dentist now, but when I get back from the dentist, I'll get the head on this, and then, yeah, be good. That might get it built this morning. Okay, YouTubers, we're on and running with Peter's engine. This is the 998 that had the crack liner, that we put one liner in it with our fingers crossed, and then I ended up boring it to 73mm, so it's now a 1012cc. I wasn't planning to run it because I was busy on with my little posh cylinder head Carter engine, but the chap who's doing the work for this lad, he basically ran me and said the new engine they got to fit in the car didn't fit. Has he got a sump? And I said, well, I haven't got a sump, but the engine is ready to run. So he said, really, if we could put the original engine back in the car, that would be amazing. So I said, well, I'll run it for you today, and then come and get it tomorrow morning. You can have him back on the road in no time. So I said, I'll put it on the dyno. So I've had it idling and trying to bed in all morning, because obviously it's on new piston and it was on a tight tolerance. And I've run it up. It runs sweet as a nut. It's got really good oil pressure, and it's got half right torque as well, to be fair. It's on Stromberg's. The cam that was stamped up R17 measured the same as an Imp Sport cam, so I'm not sure what's happened there. I just saw casting numbers on it, you know, with the 157 last 3 letters, and I thought that's an Imp Sport cam, that. But and I thought, how's it got an R17 from that? There's not enough meat on it. And then when I measured it, it was an Imp Sport cam. So consequently, it runs really well, because an R17 on Stromberg's is a bit lumpy, but this is sweet as a nut. So wind it up. So at 5,000 there, I'm not prepared to go much higher. It's got about 65, maybe 66 foot-pound at 5.5. Sure could do a calculation for, but I don't think it's much. What about 65, 70 horsepower? But it has got some good torque. If I put some load in the dyno, I'm holding the camera today because the stand is in the back, and I've got to rush home because we have a poorly child, so I have to go and pick him up from school. So I thought I'd better run this and ring Mike first. Anyway, a bit lower now. So 4,000, yeah, 67, maybe 68 foot-pound. Oh, I've gone past, maybe 70 foot-pound at 4.5. So brilliant. It's not breathing or anything. It's got great oil pressure. I think we'll put that in the out tray and tell Mike he can come and get it in the morning. Right, YouTubers, this is the 998 that we turned to a 1012 that we ran last night. It's now Friday morning, and I've got a special guest in the workshop. Some of you guys might recognise. It's Mr. Mike Dent. How you doing, Mike?
All right, Andy. How are you?
Very well, thank you. Thanks for agreeing to come on Shrigleytube. Now, I've just got Mike on. I bullied him into coming on to Shrigleytube. I said, we just need to know the story behind how it ended up here with the smashed up piston. So the engine was in the car, yep. And were you just recommissioning the car, were you?
Well, it had a few reliability issues and whatever, so we were trying to sort everything out, and I tried setting the timing, and I couldn't get that right, which we eventually traced to the bolt missing out of the front pulley. So yeah.
So the pulley had come forwards, had it?
Yeah. So every time you move the rotor arm, you could push the front pulley out, so we could get the timing right. So we found that. I've
seen that before, because the skew gear just slides on the end of the... It's dead common, that, you know.
Yeah, so we got a bolt, put the bolt in it, got the timing set, and then we balanced the carbs up and checked that, and went out for a drive, and it was going so much better. And then on the way back from the drive, as I slowed down at a junction, I thought, oh, it's idling very, very high. So got back into the workshop, it's idling very, very high, backed the screws off, and nothing. So I thought, well, we've got a big air leak past the butterflies. So took the carbs off, and lo and behold, we found a screw missing out of one of the butterflies.
Oh no.
So we found the others were loose, so we got a new screw, we Loctited it all in, and then I had to ring the guy who owns the engine and say to him, that screw could still be in the engine, or it could have gone out down the exhaust.
Yeah.
And it was idling high when we drove back, and it hasn't done any damage so far, but it's your decision whether I drive it any further. Anyway, we made the decision to drive it further, went out for another test run, it's going really well. And then all of a sudden there's a bang and a cloud of smoke. So I thought, oh, it's done the head gasket. And we did have doubts about the gasket, or as it turns out, wheels rings on this engine.
Yeah, yeah.
So got it back, gave him a ring. Anyway, we pulled the engine out, took the cylinder head off, and that's when we found all the damage that you'll have seen on the video from last week.
Yeah, yeah. The piston's hanging around somewhere. I don't know what I've done with it, but it's well and truly squashed the top ring in and etc. But I did just try and put our liner in it, but ended up putting a liner and then boring it. But we'll give it a quick run. Thanks for agreeing to be on Shrigleytube anyway and telling a little story there. It does run exceptionally sweet. I was quite pleased to see that it has an R17 cam stamped up as an R17, but it's actually an imp sport cam, which pleased me because a sport cam is so much sweeter on Strombergs. Hopefully it'll start first. It's quite sweet, isn't it? So yeah, so we'll get this unbolted now. I reckon by 2 o'clock you'll be test driving.
I would have thought so. The other temporary engine that we were starting to fit and ran across problems with is back out. So.
Oh, is it? Oh, yeah. Right, well, we'll get this off. We'll get the clutch bolted on, drain the oil out of it, and then you can go. I'll see you Sunday night at 7.
See you Sunday.
Cheers. Right, okay, it's time to get stuck into the Carter 1200 engine now with the deep angle head that we've got. Now, I've left this to midweek because I've been doing those other jobs. While I was doing the other jobs, I was thinking about a plan of how I was going to go about machining pistons, etc. And sometimes you just need that little bit of time, or I do anyway, just to stew over in my mind what my plan is actually going to be. So I thought, right, rather than strip it to a million pieces, I'll put the new pistons in on the rods, and first of all get a piston height so I know what's got to come off them, etc. And also what I do is I want to make valve cutouts. So as we discussed last week, this is now an exhaust when you can clearly see it's an inlet, and this is now an inlet when you can clearly see it's an exhaust. That's because the imp head is a different way around. So the imp starts off with a inlet valve exhaust, whereas this starts exhaust, inlet, inlet. So we've got to remachine the cutouts in the pistons. Now, because this is not knife and fork, but because it's been done old school style, I don't think it'd be very easy to measure the correct position to start the starting point for the valve. I have been here before and measured one on another engine it was, and then I machined all 4 pistons the same, and then when I come through my dry build I had valves kissing edges and all sorts because the head wasn't uniform. It's not been made on a CNC, it's not like a modern engine. So what we'll do is 2 at a time. We'll bring 2 pistons to the top, put 4 valves in, we'll drop them down with a bit of engineering blue on the edge, and we'll see where they land, and we'll mark it with the etcher, and then we'll number that piston for that pot, and then it'll go over there, and we'll get it on the milling machine in our jig, and we'll machine the piston cutouts. Now, I was just looking at the head, and it's got some really funny bits on it that I'm just a bit unsure of, so I thought, well, we could always ask the viewers. There's lots of clever viewers out there. So it's got these 2 threads here, and I was trying to work out, the welding is lovely. It's got to be in Carter to do that sort of standard of welding on an imp. I don't know anybody else that had worked to that level. But the interesting thing is the hole comes through to this side. So I was beginning to, I looked, and if you zoom in here, you can see there's a hole there. Now, before valve guard oil seals were made, or, you know, in the 70s when the people used to drain the oil away rather than that, I wondered if the engine had been in an installation, let me turn this out, take the camera out, where the head was set as a vertical downdraft like that. And then what these holes were for the oil to drain back down to the sump. Because I can't see any other reason why it goes to that trouble of welding it. I've obviously welded it and put some sleeves in because it has to pass through the water jacket, I imagine, inside there. Anyway, that was that. So that was the first question. And then another thing was looking at the head, and I'm thinking, crikey, it's had some weld in this. You can see bits of porosity in it if you look closely around here. So it's had a bit of work, well, it's had a lot of work. So it's either been smashed up or it's collapsed. So when I look in here, you know, we put the support screws in. We'll just zoom in. I'll try and get the torch. You see that big void behind there? It's a massive hollow. So I reckon there's a chance that when this is wheels ringed, it's so thin that I don't think this whole area is supported from the back side of the chamber. It's all a hollow. So what I'm going to do at this stage is, the thickest part of the material is here, I'm going to set up on the miller and I'm going to come in at an angle with a 1/4 UNF grub screw, and I'm going to make it so that it lands around about here on the back of it, so that when we clamp the head down and the wheel string puts pressure and wants to push the head that way, the forces will be transmitted up into this flange here where it's quite thick. I was going to do it here, but it's just dead thin. I can see that you know, it's just, there's just nothing to it, and it's not going to be a decent purchase for it. It's really thin. So we'll do that, and that'll hopefully give us a half a chance of this part of the chamber remained in good shape. It's definitely head thin, this head, compared to the one that I've got, because these threads are really close to the edge as well. It's had quite a lot of material off it. Now on this side, it's not the same problem, because if we shine the torch, you'll see that this part of the casting here is bridged to the back of here. So that should all be quite strong, all that. Anyway, just look at that inlet port angle. How beautiful is that? That is going to be a real nice flow, that, I'd imagine. It's got real good turn on it. So yeah, I'm quite excited to see. They're not overly big, the ports, and the valves aren't overly big either. But I'm not going to mess with any of it, because I think there's a good chance that someone far cleverer than me designed it all. So I'm just going to run it with the valves that have come with it. I've got to be honest, the valves I'm happy to use. They're one piece and they are stainless, and they look good, so I'm happy to use them. But all this we're going to have to put in the bin, I'm afraid. It's just, these are old, you know, the new old springs, but, and I think they are steel caps. They look like Lotus Cortina ones, to be honest. But all that's going to go in the bin. We're going to put it on some new titanium valve caps and some modern bob springs, and then also the fitted length, the seat pressure was enormous. You know, at no lift, it just doesn't need that much spring on it. So we'll make it similar to an imp, because this reciprocating mass and that bucket, it doesn't need like 75 pounds at no lift. It needs more like 50. So we'll sort that out as well, but we'll come across all that when we go through it. Let's get some markings on these pistons and see where it all sits. Okay, I found this picture on the internet. It's a 1000cc 997 Ford, like a pre-cross flow block out of Anglia, with an SCA Cosworth cylinder head. You've got to ask yourself if the same people that designed the Climax job were also involved with that. Just place the head on top of the block, so that I can see with the two pistons at top dead centre on the centre two cylinders. And I put the valves in just so I can see how much clearance. Now this is now, is that an inlet valve? Yeah, that's an inlet valve. And I can see that because it's obviously a bigger diameter than the original exhaust cutout, it's hitting, I've measured that. So we've got 90 thou, and we need about 250. Now the inlet side, the exhaust side on the inlet cutout is different kettle of fish. That's got 220, which is actually okay, because we've got no wheel string on at the moment or paper gasket, so the whole lot will be 20 thou further up when we run it in as a build. So believe it or not, we're not going to do anything on the exhaust side, because the inlet cutout is already in the right place, or it's big enough, should I say. But we are going to have to sort out the inlet valve. So let's pull the head off and see where it's made any marks. Right, we just pulled the head off after marking the piston. And if I zoom in, hopefully you should be able to see that's the point that the valve has been kissing. So that's our datum. That's where we're going to start machining from for the inlet valve. Same with this one, similar position. So we'll work out the centre, and that'll be our datum. Now on the exhaust valve, it's only just start. Can you just see it kissing on that edge there? It's just kissing there. So I'll just put a tiny bit of a chamfer on there. Just use the hurdy-gurdy just to remove a bit of material, because although the top ring is quite far down, I don't want to weaken this area, because it does appear that this is the area that an imp piston fails on, if it given half a chance. Same with this one, it's just caught him. See, it's just caught him on the edge there. So we'll just fluff that off a little bit. We'll probably put some nice radiuses on all these edges as well, because I never like sharp corners on my pistons and my valve cutouts. So great, I'll repeat this now for the other two pistons, and then we'll get on the miller and start machining the pistons. Just on with making a jig to hold these pistons so we can machine the valve cutout. So I've got two flats here that I want to use to index off, and there's also a turn diameter inside there. So what I've done is I've just turned this little peg down and made it quite tight. What will happen is when the piston is held with a clamp, that face will sit on that shoulder, and then the piston will be in a secure position so that we can come in and do the valve cutout. That's the plan anyway. Okay, we've got the piston now mounted on the little button that I turned for an index so that the land can sit nicely. So the piston sat real steady on there, and then I've clamped it down opposing where the flat part was, so it's definitely sat nice. So we've got a good purchase on that now, so I'm happy to start machining that. If you zoom in, you'll see what I've done. It's just rough, this, but it does work. The centre line of where the valve touched, so that you can just about make out where the valve touched there, I've put a line going that way, because when you start machining it all disappears, so you could do with knowing where it was. And also there's a line going horizontally there, just a light, oh there, that's caught it. So that's the centre of where my tool wants to touch on, and obviously once I've started machining I'll still have this bit here and this bit here to reference where I'm going. So we're going to do that probably about, I reckon we're going to go to a depth of minimum sort of 220 thou, so that with the sort of 20 thou and the wheel strings compressed, that'll give us 240, which should be ample. Now what I've done here is, this is the posh head. I've set him up on the horizontal, zeroed the gauge, and then I've just pulled a valve open, so you can see the valves are at 9.35 degrees, whereas on an imp they're over at like 18. So it's what I call a shallow angle head. It's all to do with the way the air comes around that short turn. So the flatter the valve is, it just makes it a better turn for the air to come round. Not that I'm going to confess I understand any of that, but we'll get William on it one day, he knows all about that. But it's all to do with air turning and not wanting to turn, and fuel inside the air buoyant, and all sorts of clever things like that. So this little device here is like a swivel vice, or not a vice, a swivel bed we'll call it, probably got a professional name. I've undone the clamps so we can move it. So all we've got to do now is transfer this over onto here and set it at 9.35 degrees. He says it's all gone tight. So I'll set that at 9.35 degrees and then nip it up, and then that should be the perfect angle then for our valves to come down with this cutter, and we'll make some cutouts. Okay, I've just touched on with the tool. To zoom in, you can see I've measured the amount of contact either side of the centre line, and it's pretty much crack on where I want it to be. So we're going to go down now and machine a new valve pocket for the inlet valve. I'm not concerned about breaking through, because this is the back of one of them pistons, and you can see on this side it's full body. Obviously it's machined away for weight on that side, so in theory we can easily go as deep as this side without causing any structural issues in the piston. Quite often you see them wasted at the back, so they're quite lightened heavily, and that means that we could run the risk of breaking through, but this piston will be absolutely fine. And then over here, I nearly forgot to mention this yesterday, this is the tall 5 bearing sandcast block of Glenn's that we're doing the pistons for, and he said, would you skim the block for me? So I skimmed the block for him, and I had done it previously in the past, so it wasn't actually bad, but it's nice that it's all got a nice fresh surface for the gasket and the wheel strings to seat on. Now what I was going to say was, I didn't video it actually, but when it's going across it takes all morning, because I have it on the slowest feed and I only have it at 80 revolutions with my homemade fly cutter. Just a tip squashed in there with an M6 bolt. Now the reason it goes slow is because if it was aluminium we could have it flying around at 300 RPM and we get a nice finish. But because we've got iron in the liner and aluminium around the outside, we have to set the tool so it cuts the iron and doesn't rub, because if it goes too fast it goes shiny and it rubs, you don't get a perfectly flat surface. So when it's nice and grey like that, it means that the tool hasn't rubbed and ridden over the top of the material, it's cut it, 'cause it's like da-donk, da-donk, da-donk. Anyway, I should have done a video. I'll do another video of it when it's machining it and you can see for yourself. Oh, okay, we've just done the exciting bit. Just machined this piston, managed not to scrap it, which was quite handy. Something that I didn't foresee, and you often don't foresee these things, is because the angle is so much shallower with the new head, the pistons had to have quite a lot of material off here. So when I said the exhaust valve was catching in the corner there because I couldn't see anywhere else, it was actually catching there because it used to come in at this angle and now it comes in at this angle. So I've had to take that off. So we're going to have to be really careful. Well, saying that, the head's quite shallow. I was going to say we'll be really careful with our compression ratio, but I think we're going to have an abundance of compression because if we look at the chamber, it's really small. So we'll work all that out when it comes to it. Let's just get the pistons correct first. So you'll also notice I haven't gone full depth to the same as this, and that's because it's not necessary. I've now got 160 thou from here to the bottom of that depth there, 4mm, and I've also got 90 in the head before the valve hits the piston. So the 90 plus that gives me 250. So I'm happy now that I'll have enough clearance on full lift. But what we will do, of course, is when I dry build the engine, I'll put all the valves in the head, dowel the head to the block, and I'll make sure they've got the drop and the clearance, because we can't have valves interfering with pistons. It can cause a lot of problems, not always straight away, but later on down the line with jarring the valve gear up, and also has a nasty habit of breaking the valve off, which is not ideal. Anyway, that's all good. Dead pleased with that. Just got to repeat it for the rest of the pistons and then we can get on with the drive. Good morning, chaps. It's Saturday morning. I had that much time off in the week that I've had to come in Saturday morning to catch up. We've had a bit of a poorly child week, so I've had to finish early and start late and all sorts of messing about. Anyway, come in for a couple of 3 hours this morning because my old boss, Bob, he's bringing his Mini down for MOT, and I thought, oh, I'll see if I can get him to show me around the Mini for you guys, because it's a cracking little car. It's a Mini ERA. Anyway, hopefully we'll get a video of that shortly. But I just realised I was steady away with my pistons, me modified pistons, and then I realised that I've got Tim from Merlin coming over tomorrow to pick up his engine block. Now, I said I'd do a rear oil seal conversion. He posted it over to me, and I thought, oh, I don't think I've done anything about this in the past. So I've got one not done and one done, and I was going to talk for a minute about how it works. So we'll start with a standard imp engine. This is a standard Hillman imp engine, and it doesn't have a rear oil seal in the back of the block. It uses something called a scroll seal. Now, don't confuse this with a Talbot Sunbeam block. The Talbot Sunbeam engine, which you can probably find the example of one quite quickly, like this one here, has a housing for a seal in the back of it. So that's that one. That's the later engine. That's what they put in the Talbot Sunbeams. But all the Hillman imp engine from start to finish of the Hillman imp production ran with what we call a scroll seal. So this diameter here is fractionally, like thousandths of an inch, couple of three, bigger than this scroll. And the idea is that the oil, it gets caught in the screw in the close diameter. So all the oil gets wound back. And you see this slightly larger diameter here, can you see it's just a bit bigger? That's called a thrower. So obviously it's spinning centrifugal force, flicks the oil off that big diameter. Any that gets past gets on the scroll and the screw winds it back. Now, when the breather on the engine, as in the engine breather, you know, where the oil filler cap is full diameter, not just a little snout on the side, the scroll works quite well. But as you can imagine on an imp, because the car goes this way, when you go circuit racing with them and you press the brakes hard, all the oil comes up to this end of the sump and it just pushes past the scroll, and then it goes on the flywheel and it flicks it off the flywheel, and it all ends up on the inner wing and all over the back of your car. So you have to do something about it for racing. Although people have raced, you know, we've done various different ways of making it so it's not too bad, but the breather system is critical. If it's got full atmospheric breather with no crankcase pressure, that is your best chance of making your scroll work. Now, what's happened is, in recent times, Mr. Mark Maynard decided to make a smaller seal and an insert. Very clever, this little insert. It goes inside, see that diameter there? That's the remainder of the scroll diameter. So all I've done is machine clearance in. In fact, so this is on clearance, this. So the glue goes around the outside of there, but it isn't actually held in by that. It's just clearance. It's held in by this diameter. So obviously it goes that way around. So it won't go in now because the cap is torqued up, but that will sit flush like that. And then you put the seal in, and you'll have seen it on plenty of my engines. And it actually works remarkably well. Certainly if it's not 100% oil tight, and you do get a little dribble every now and again, especially on the racers, but it doesn't splash it everywhere like it does on the road going car when you try and race it. So all I've done is I basically centered on that rear main, and I've come down with the different tools and machined it out to a diameter, and then put a nice chamfer on it for the glue to sit, and also make sure it sits down flat. So that basically is how we do a rear oil seal conversion on a hill. Bob has just popped into the workshop in this mini, is it a mini ERA, Robert?
It is, yeah.
I'll make you a cup of tea in a minute. Okay. It's stunning. I like the colour. It's the same as my Audi, that. Is it emerald green?
I don't know what it is. It's green.
British racing green with a bit of a tint in it. So how long have you had this?
I can't remember now, but it's a few years.
A few years. And is the running gear like Metro Turbo?
Some of it is, yeah.
But it's a bit special, isn't it?
Brakes are.
Brakes are.
Gearbox.
Wow. It's A series still, not the K. What year is it? On a G90?
Yeah.
Oh, I like the plate. Yeah, that's cool, that. Where's your headlamp rims gone? Oh, right. Oh, right. It's cracking, that, Bob. Can we have a look at the engine? In fact, I think you should take me on the road in it. Is it fast?
No, not really. It's just all right.
Just all right. That means it's fast. Bob's not easily wowed, is he? Oh, you have to help me out here, Bob. It's technical.
It's too new.
Too new for me, yeah. It's got a bonnet catch. Wow, it's busy under there, isn't it? What's this? Oil cooler?
No, the aircon.
Air conditioning? You are pulling my leg.
Yeah.
Wow. It's got air conditioning. It blows through an SU.
Yeah.
And it's got a turbo. Is it a guarantee free?
Don't know what it is.
There used to be,
If you want to go and have a look at it, it's right.
Yeah, it's right down there, isn't it? Wow. It looks very, very original, this, Bob, and unmessed with. Crikey, there's not much space for anything, is there? That's a good little guard, isn't it? Power steering. Oh, no, it's not power, it's air conditioning.
Yeah.
Wow. I wouldn't like to do it. Mind you, the head gasket might not be too bad to do, might it?
Maybe.
Has it had one yet?
No.
Wow. It's lovely, that, Bob. Just in case you didn't realise, Bob is my old apprentice. He used to work for me back in 2006, and he's done quite well for himself. I think he built a business based on what he learnt off me. No, you're all right, my mate. I put a clamp on it, £50 release fee, yeah?
I've left it in the letterbox.
See you later. Right, well, Bob, thank you very much for showing us around. Do you think we can go for a little drive up the road? I want to feel the boost.
Do you struggle to feel it?
I doubt it. I bet it's quite quick. There was two of these when I lived in Jersey. There was two of these in a shed near Gorey. I used to drive past them on the way to Gorey, and I knew there was something special when I saw them then. They even got ERA hubcaps. It's cracking. Got his car on the MOT ramp. Let's have a look and see if the sills are made out of paper mache. Alright, it's got floors, this. What's it like, Philip? Is it a good one?
It's a beauty. It's an absolute beauty. Look at that.
It's got 4-pot calipers on it.
Yeah. Spats adjustables.
Mate, there's no rot on it at all, is there?
No, it's brilliant.
Been garage this, hasn't it? It's even got like twin brake flexes.
Yeah.
Is that the engine?
This is a beast.
Crikey. Looks heavy, that engine. Looks real heavy. Grease nipples as well. Look at all them grease nipples.
Don't see them anymore, do you?
No, designed to last.
Yeah.
Let's look at the back. Where's the transaxle and the race engine? Oh, it hasn't got one. It's not an imp, is it? Oh, look, it's got a Bosch 044 or similar. High pressure fuel pump. I take it that's all aftermarket, isn't it? Because it wouldn't have had that as standard. Is it? What did it have a standard, Bob?
I don't know. I think it was in the tank, you know.
In the tank. Yeah. Lovely. Coilover conversion there. Very nice. Very nice indeed. Hey YouTubers, not many of you will know where I am, but I'm in Chapel Street, North Wales. Just brought the van to pick an engine up, and this place is Merlin Motors. It's not anymore because Vince is sort of semi-retired. He just does a bit when he feels like it. He's a man of leisure. He's retirement age. Fair play to him. Now Vince used to have this place. This forecourt was absolutely chocker with Hillman imps, and an old Land Rover as well, which was like a spec lift on the back of it. Such a shame. I hate change, but there is some nice bits to the place. I was just saying, Ernie, how much I loved how it used to be. Look at the office. It's proper old school. I love it. Yeah, that was where the fuel pumps were. Oh, look at this. Look at this racing car here. Wow. That's what we did at Oulton Parking. What year was that, Ernie? 21?
Something like that, yeah.
Come on, let's get you on the video. This is Vincenzo Frostini.
Oh, go on! Go on, lad!
He's also known as Vince Frost. But yeah, this is where it all happened. When I was about, it's got to be, I don't know, 30 years ago. No. Yeah. No, 2000, around, no, 99. I brought my 998 here. We were going racing for the first year, and Vince said, bring it up and I'll rebuild it for you. And we put some brown paper on that ramp, and you rebuilt it all. Remember? Yeah. And Kev Dreads came along, and all the old bits that were left over, he took them away, didn't he? Right. To build his own engine. Yeah.
Happy days, eh?
Happy days, mate. Oh, wicked. Right, well,
There's another day though, isn't it?
yeah, you'll be out next year. You'll do a bit of something, won't you? Yeah. You fancy doing a bit of CTCRC? Yeah? This place is full of Hillman goodies. Look at the Hillman bits everywhere. What's this brand new wing off? Do someone that? Peugeot. 406. Crikey, is any of them left? Yeah. If you can find someone with a Peugeot 406. I think the Africans like them. Yeah. Where's my engine?
Your engine? Which one?
Mike the Mower's engine.
Eh?
Mike the Mower.
Mike the Mower's engine?
Yeah.
Oh, it's in here, yeah. I went track tested it.
Did you? Was it any good?
Yeah, it's great. We didn't take about 10.
I love it.
Yeah.
Oh, brilliant.
Yeah, you can have my old one in exchange.
It's done a bit, this engine, Vince. Yeah, I keep threatening to take it out and rebuild it for you, don't I?
Yeah.
How many seasons has it done now, Vince?
About 5.
over a 40-year period?
Yeah. Probably done about 30 races or more, 40.
Wow. When did we first start doing the racing, Vince? Was it about 97?
2002. Hill climbs.
No. When did we do the hill climbs?
98, was it? Something like
98, yeah. I was Cheshire Component Development Systems, and you were Merlin Motors.
Right,
and we had each other's writing on each other's car, didn't we?
We did.
I had a turbo imp.
Yeah.
And we were pretty level, really, weren't we?
Right.
Yeah. You had another car then. It was called Hock's car, wasn't it? Or what was it? Yeah.
It's a rally car now, isn't it?
It is, yeah. Belongs to Terrible Terry, doesn't it?
That's right.
Yeah. Shouldn't say that, should I? Lovely Terry, I mean.
Yeah, he's all right. Terry.
He's a belter. Yeah. Oh, well, thanks for being on the Shrigleytube, Vince, and showing us around. Is this my Mark 1 here? I love this one.
Yeah.
It's a belter, that. Make a cracking project.
Name on that.
I know. This has been in here since your Beth. Your daughter, how old's your daughter now, Vince? About 30? 40. When I used to come here, she used to be a little kid, like 10 years old, cleaning gearbox cases for you in that. That was when there was a few blokes working here, all mechanics.
Yeah.
Oh, mate. Reminiscing here, aren't we? Look at all the engines. This is a lovely Mark one, this. I love them. If you look inside, folks, this is what we call a steel ended. So the end of the dashboard there, see where it's blue?
Yeah.
That means it's, is it like the first year or first 6 or 8 months?
Yes, it is, yeah.
Of production. So it's a really early one, this.
Yeah.
Okay. It looks like you've washed it, Vince, because it used to have more dust on it.
Yeah, it's probably the wind last week. we had the storm last week.
Brilliant. I love it. Right, thanks for showing us, Ernie. I'll over and Vince has just let me into what's known as the Emporium. This is a very, very special part of the workshop. Mate, look at the Husky. It's absolutely mint.
It's Dot's Husky, then.
Dot's Husky. This is Vince's wife's car. Look at that. Yeah. Can I have a smell? Oh, mate.
Smell.
It's beautiful, that original carpets. But although I'm excited about the Husky, there's something else behind you, Vince, isn't there? What is over here? Can I buy it? I love it. Look at that. A special saloon.
Yeah.
From back in the day?
Yeah.
Wow. And do you know who it belonged to?
Well, I got it off the guy. It's down south, but I think it might be moving brake or something like that.
Right. It's got the original floor pan in this one.
Yeah.
So it's like a space frame front and rear.
Gear changes above the...
Oh yeah, the gear change is above. So the whole cross member's been raised, has it? Ah, that's clever, isn't it? So the whole lot's higher, so the car can be lower.
Yeah.
God, it is low, isn't it? Look how low it is.
Yeah.
Doesn't help the tyres are flat. So what's in it? 998?
It's a car to 998.
A car to 998?
Yeah.
A real one?
Yeah.
Oh wow. Let's have a quick peep. Hope there's enough light in here for the cameras to be able to pick up on it. Oh, and it's hung off the back as well. Oh, genuine Ian Carter engine. Yeah, it's probably seized up. The best I can give you is £100 for it.
Right.
Is that okay?
Yeah.
Yeah. Oh, you're a diamond, Vince.
Well, the photograph of it, you mean?
For £100 for a photograph. You need to get this recommissioned, Ernie.
Yeah, we're going to have a play with it this year.
It's not. Doesn't look like it's far off. It looks solid and everything.
It's solid, yeah. Just wants the pics, yeah.
It's got like a big bulkhead there. That's for accesses with the engine higher, I suppose, is it?
Yes, higher up.
Oh, look, and the raised the shock mounts as well.
Yeah.
That's interesting. Clever how he did things back in the day, isn't it?
Yeah.
Look at that. Let's crack at that.
We'll have a track day in Anglesey with it in the summer.
I'd love to, mate. As the kids are getting older, it's getting easier and easier. I can feel it. There's going to be a lot more racing going on next year. Vince very kindly got his photo album out and showed me some pictures of some old racing imps. So these are all from Oulton Park, some absolutely cracking pics. I'm sure a lot of you guys will recognise some of these cars, proper old school space frame imps at Oulton Park, and the old Oulton Parks, Aston Martin in the background there. And even an imp with the a Hewland gearbox and an imp engine mid-mounted. That was quite an interesting looking car. But for me, the pictures like showing the old cars and Oulton Park, that's the bridge that used to go over the main straight. And in the background there, that's Checkers. That's the old Checkers on the inside of Old Hall. Used to have a great cafe, get a good breakfast in there. And the scrutineering bay next to it. Yeah, that's the old scrutineering bay there. It's just great how it used to be. I do still love Oulton Park, but it was much better when I was a kid. Anyway, I'll let you enjoy the pictures. This last one is of Jeff Ward, is it? He's a proper grief and absolute flying machine, that. Brill. Congratulations, YouTubers. If you're still awake, just over an hour, well done. Hope you enjoyed the pictures from Oulton Park. That was my favourite bit, just loving them competition cars and all the old cars in the background as well. A bit of reminiscing going on, and the bridge over the start-finish straight, and of course Checkers on the inside of Old Hall. Absolutely cracking place. I still love Oulton Park now, but I did love the way it used to be. Anyway, we won't go on about that. I hope you had enjoyed tonight's video, and I look forward to seeing you next Sunday at 7. Have a great week. Bye for now.